So what my lab thought about Rett syndrome was that the literature is very confusing. MECP2 turns genes off, it turns genes on, it binds RNA, it does lots of things, and it seems that when you lose it, a lot of genes are going up and down, and we didn't feel that we really had a handle, that the community really has a handle on exactly what causes the symptoms and the disease. So we thought that an approach used in a number of model organisms, including fruit flies, could be applied to Rett syndrome and be used essentially understand why everything's going wrong and if there's anything we could do to fix it. So we employed something called a suppressor screen, which is essentially where we would ask, can two wrongs make a right? So we have a mutant MECP2 model, mouse model, and we're asking, can we isolate a second mutation that normally you might think of a mutation as being bad, but in this case we want that suppressor to improve the outcome of the detrimental MECP2 clinical signs.
And what are the results?
So at this point we have done a lot of screening on this. We have screened over 3,000 genomes for improvement of symptoms. We have isolated over 90 lines of mice that show great improvement of symptoms. And we use a strategy nowadays called next generation sequencing that allows us to sequence the whole genomes of these mice very quickly and easily and cheaply to identify candidate genes for suppression. And in doing this, we have discovered that we're finding genes that lie in common pathways. For instance, mutations in genes that would regulate other genes, but then also those target genes. We're finding genes that MECP2 would function with. But we're also finding genes that would affect the improvement of neural synapses, which is kind of what you'd expect. But then we found two pathways that are completely unexpected, and one of those is in a pathway that makes choices in cells about how they're going to repair DNA damage. So all of our cells go through damage all the time. And this is a choice in how that damage is repaired that is different. And the other pathway was entirely unexpected as well, has to do with cholesterol metabolism. So you probably know about cholesterol. You don't want high cholesterol, right? Because if you have high cholesterol, you get heart disease and you might have to go on statin drugs. Well, long story short, we found a mutation in a cholesterol synthesis enzyme that led us to discover that these MECP2 mice have an abnormality in that they overproduce cholesterol in their brain, in their peripheral organs, like the liver. And we found that what is going wrong is that MECP2 is required to anchor a complex, a repressor complex to DNA to regulate a lot of lipid synthesizing enzymes, including this cholesterol synthesis enzyme. So I compare it to, in this case, MECP2 and this co-repressor complex would be like the conductor of an orchestra. They're telling it when all these genes, when to go on and when to go off. So we found a key entry point into therapy right there. So if you think about cholesterol, you think about statin drugs. They're overproducing it, so we decided to treat the mice with statin drugs, and it improved symptoms greatly and alleviated this lipid buildup. And so statin drugs have now gone into a small preclinical trial carried out by a physician that works in New York in the Tri-State Rett Syndrome Clinic. Some of them do. So that became the first question after we found this. And what we had discovered in mice is that if you put MECP2 on certain strain backgrounds, they have high cholesterol just from their blood. If you put them on other strain backgrounds, they don't, but they still get lipid accumulation in their brain. So we predicted that only certain patients would have high lipids in their blood that you could detect by drawing blood and doing a lab test. And in fact, we found that we and other groups, there's 3 groups now that have found this, that overall if you average it, cholesterol is high overall compared to normal controls. But we have found by parsing out the patients that about 50% of the patients have abnormal high lipid parameters, including cholesterol and triglycerides. So our prediction is that these high lipids in the periphery would be a very good biomarker for whether these patients might respond to statins or not. And they'd be very easy to put on because you can go on statins because you have high cholesterol.